Hello everyone. So here we are solving the fifth problem from RMO 2019. So this is a geometry problem, a pretty involved one. So let us first read the problem statement. In an acute angle triangle ABC, let H be the orthocenter and let DEF be the feet of altitudes from ABC to the opposite sides respectively. Let LMN be the midpoints of the segment AH, EF and BC respectively. Let XY denote the feet of the altitude from LM onto the line DF. Prove that XM is perpendicular to MY. So this is a pretty involved problem, I think. Like you can prove it using elementary method, but the solution I'm going to present involves some homothety and some nice properties of triangles. So hopefully you will learn a lot from it. So firstly, let us prove a small lemma. So let me state the lemma first. So to show this lemma, let me draw a diagram and show this lemma. So suppose this is the triangle ABC, and suppose we draw the altitudes. Suppose this is E, this is F. Then this it is well known that BF ECR cyclic. We can easily prove it using angle in the same segment. So let this be the circle. So what I want to prove is that first let me draw the third altitude. Yeah, suppose this is D. I want to prove that suppose FD intersect the circle again at E dash. So E dash is the reflection of E over BC. So what we want to prove is basically that E dash is the reflection, which basically means that this angle is 90 degree. So this is what I want to prove. This angle is 90 degree. This is what is needed to prove, because see, the center of the circle is the midpoint of BC. So let us denote this by M. So if we prove that angle this angle is 90 degree, like suppose this point is X. So if angle EXC equal to 90 degree, then we are done. We have showed that this is E dash is the reflection of E. So how do we do this? So this is a pretty simple angle chase. So suppose this angle is alpha, angle BDF, then this angle is also alpha. Okay. And if this angle is beta, the green angle, suppose this is beta, then this angle is also beta by angle in the same segment. So notice by properties of altitude and all, we already know that alpha equal to alpha equal to angle A and beta equal to angle 90 minus A. This is because see, this is alpha, so because DFAC cyclic, we get that this angle is alpha. So alpha is angle A, and similarly because this is 90 degree angle BEA, we get that angle beta is 90 minus A. So alpha plus beta is 90, and so dx e dash is all 90. So thus we have proved the result. Basically, I am not gone into much depth. This is a simple lemma. You can easily prove it using angle chase, as I have done here. So this is the lemma. The lemma states that e dash is the reflection of E. Basically this in the diagram. So notice what we get from this is that suppose we join Fe. So if we take a homothety of ratio 1 by 2, then let me write it down properly for better understanding. If homothety of ratio 1 by 2 is done at F. So what are the changes? So E, let me draw the diagram once again, a smaller diagram. So I'm drawing a very simple small diagram. So suppose this is F, E and E dash, only this much, like this part of the diagram, this small part. So F, E, E dash. So if you consider a homothety of ratio half, E goes to the midpoint of Fe. So, so suppose the midpoint of Fe is M and this goes to some other point, say N. So N is the midpoint of Fe dash. So this is what it goes to. And notice by this we get that Mn is parallel to EE dash by the homothety. And notice that EE dash is perpendicular to BC. So from that we get that Mn is perpendicular to BC. So this is the result that we are going to use. So let us go to the problem statement now. So I've already drawn a diagram, a very rough diagram. So first let us do some angle chase. So first let me draw a small diagram of quadrilateral like A, F, E, H. So this is cyclic because the opposite angles sum up to 180 degree. So this is cyclic. So because angle AFH is 90 degree, so the midpoint of AH is the center of this circle, and by the problem statement the midpoint of AH is L. So L is the center of the circle. So L is the center of the circle. Notice that if we connect the center of the circle to midpoint of any segment of the circle, so if what is the midpoint of FE? FE, the midpoint of FE is M. So if we connect LM, then LM is perpendicular to FE, because if we join midpoint of any chord to the center, the resulting line is always perpendicular. So this is what I wanted to say. So if this is L, this is M, M is the midpoint of FE, so LM is perpendicular to FE. So basically in our bigger diagram, this small angle is 90 degree, and so I have proved that. Now let us do a, so this point here is F. So let us now draw a small diagram of, so this is F, M, L, X. So this angle is 90 and this angle is 90 degree as we just proved. So we get that X, L, F, M is cyclic. This is what we get. And now let us join the chords. So let me first erase the perpendicular angles here. So notice that, let me draw by another color. Yeah. So this angle will become equal to this angle. So angle FXM equal to angle FLM, and we already know FLM because let us draw the, let us draw A, F and E and H again. So this is the diagram with another color for visibility. Yeah. So as I said earlier in the earlier case, the white quadrilateral is also cyclic, and L is the midpoint of the white quadrilateral. So, and notice that this is perpendicular. So this is perpendicular as I just proved. So notice that because this is perpendicular, we also know that in a cyclic quadrilateral, we know that triangle FLM is congruent to triangle ELM. This is E. Yeah, so this is also equal to blue angle, and this is angle FLE equal to twice of angle FAE, which is equal to angle A. So what we basically get is that the blue angle equal to angle A, because see, two blue angles make up two A's, so one blue angle is equal to one A. So we get that angle FXM equal to angle A. So this is our first important result. This is our first important result. Yeah. So secondly, let me copy one diagram, this diagram again. Yeah. So this is what we get. And notice, as I by the lemma I proved earlier, wait, first let me draw some another small diagram. So suppose this is F, this is M, and here somewhere is Y, and here somewhere is N. Yeah. So this line is connected. So what we get is that, notice that N is center of N is the center of the cyclic quadrilateral BFEC. So basically this is a cyclic quadrilateral, as I just showed. This is well known that this is cyclic, and N is the center because N is the midpoint of BC by the problem statement. If you have read the problem statement, so N is the center of the circle. So N is the center of the circle, and by the same criterion we just used now, we get, if we drop a perpendicular, so this angle is perpendicular, angle NYF is equal to 90 degree by construction. So because this is perpendicular, and suppose, imagine just that we draw a circle, this big circle, and we extend Y. So when we know that this E dash, as I just proved earlier, so Y has to become the midpoint of FE dash. So Y is midpoint of FE dash, where this upper point is F. Because if we drop a perpendicular from center, it meets a chord at its midpoint. So by the same homothety condition, let me show it to you. So by the same homothety condition, note that our point Y corresponds to this N. So basically this Y is that N in the diagram. So this is the N in the diagram in that previous diagram. So what we just had proved is that Mn is perpendicular to BC. So My should be perpendicular to BC. So which means that this angle is 90 degree, and this angle is 90 degree, and yeah, this angle is 90 degree. Also notice that this was the point D. AD is also perpendicular to BC. So this angle is also 90 degree. From these two facts, we get that AD is parallel to MY. Yeah, AD is parallel to MY. So basically what this proves is that, let me use some colors. Yeah, this angle, this small angle, which is equal to angle DYM, if you can see, is equal to this red angle, angle FDA, and this we already know, this is equal to 90 minus A. How? Because B BFHD is cyclic, so this is also equal to the red angle, and because this angle is 90 degree, this is 90 minus A because the top angle is A. So this is a short proof why the right angle equal to 90 minus a. So this right angle is equal to 90 minus a, and add we have just proved a few minutes earlier that angle fxm equal to angle a. So let me bring this here. Oh, wait. Yeah, yeah. This is the fact. Fxm equal to angle a. So fxm. So basically this angle here, this angle here equal to angle a. So if we draw a small diagram again, so this is x, y, and m. As we have proved earlier, fxm, so basically this angle is 90 minus a, and this angle is a. So this angle must be 90. X and y is 90, which is basically what is required to prove. Xm is perpendicular to my, so x and y is 90 degree, and this concludes the proof. A slightly trickier proof using homothety, but I hope that you get all the points. So this was the solution. Thanks.